record, and then I have to share again. Okay, so I'm going to try now to record the drawing of the endosymbiotic theory. Greg, no. Okay, all right, so the endosymbiotic theory. Is that we had some sort of large prokaryotic cell, some sort of larger prokaryotic cell, and we had some other little prokaryotic cells. And this little prokaryotic cell had the ability to make ATP, all right? Color that in, all right? Then what happened is that this larger prokaryotic cell was like, that's delicious. So it went ahead and started taking in or eating that little cell. And what that resulted in is a cell that had ingested in it this other littler, smaller prokaryotic cell. So this is a smaller prokaryotic cell, all right? And eventually, what the theory states is that this little guy evolved into the mitochondria, all right? That prokaryotic cell that has the ability to create ATP, usually from oxygen, evolved into the mitochondria. Oh, I've got some people in the waiting room. Okay, cool. All right, then this same cell with its little endosymbiont saw another prokaryotic cell, and this one could make glucose from sunlight, right? So that was a photosynthetic, smaller eukaryotic cell. Sorry, prokaryotic. And so this cell here was like, again, that looks delicious. So he phagocytosed it. Remember, phagocytosis is cell eating. So we already had one endosymbiont, and then it took up another one. So eventually this cell, this original prokaryotic cell that was larger, now has two endosymbionts in it. One that has evolved that will have evolved into the mitochondria, and the other which evolves into the chloroplast. All right. So a couple things about this, a couple big misconceptions is that, so here, misconceptions. One, there were eukaryotic cells around. Very often when students talk about the endosymbiotic theory, they say that a eukaryotic cell ingested a prokaryotic cell. Not true. Everybody's prokaryotic at this point. The endosymbiont theory really is about how eukaryotic cells evolved.
Wait, but once it had the prokaryotic cell that would become the mitochondria in it, or the prokaryotic cell that would become the chloroplast, once that was inside the bigger prokaryotic cell, was it considered a eukaryotic cell then?
No, it doesn't have a nucleus yet and those kinds of things. We don't fully understand how the evolution of those other organelles. The best evidence we have for kind of how eukaryotic cells came about is the evidence based on mitochondria and chloroplasts. But at this point, we still don't consider it a eukaryotic cell. But the theory is all about how eukaryotic cells have evolved from prokaryotic cells. Does that make sense, Abby? Kind of?
Yes.
Okay. Okay, so that's the one big misconception, that there were eukaryotic cells at all going on here back in billions of years ago. The second big misconception is that prokaryotic cell ate a mitochondria or a chloroplast, and that is not the case. All right, they ate a prokaryotic cell that then evolved into a mitochondria or evolved into a chloroplast over many, 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 many years, right? Evolution is big time scales. All right, now let's go ahead and talk about the evidence for the endosymbiont theory. All right, so can anybody name any evidence?
Oh, sorry, go ahead.
They have the same DNA makeup as like some prokaryotes
Similar
or
DNA
bacteria.
to prokaryotic cells. And so when I mean I mean evidence of mitos and chloros. So we're talking specifically about mitochondria and chloroplasts here. All right, so similar, just a minute. So similar DNA, and what I mean by that is a single circular chromosome. So mitochondria and chloroplasts all have a single circular chromosome inside of them. All right, what was the question? I cut someone off and now they won't talk. I'm sorry. Anyone? Bueller? Bueller. Okay. All right, can anybody name another piece of evidence? Aiden.
That like the mitochondria and the chloroplasts have similar sizes to the prokaryotes.
Similar sizes to prokaryotic cells. Absolutely. Great. What else? Kate.
And they split apart more like prokaryotic cells.
Yeah, so mitos and chloros both grow and reproduce. Oops. Independently, like prokaryotic cells. Great. And you can literally see a eukaryotic cell, and if you do a time-lapse microscopy of some of their mitochondria, you can see the mitochondria getting bigger and then dividing. It's pretty cool. Okay, what else? I can think of two more.
They have free ribosomes.
Yes, they contain free ribosomes, which is so cool. They contain their own little ribosomes. So if you zoom in on these guys, you can see circular chromosomes and free ribosomes floating around. All right, and the last one. Anybody? Has to do with their membrane.
They have double membrane.
They're double membraned. So what I mean by that is that they have both an outer membrane and they have an inner membrane. Right? The inner one might be hard to see there. It would be like that. Right? So if we had to look about it, if we talked about the inner versus the outer membrane, which one would be more prokaryotic in nature, the inner membrane or the outer membrane of a mitochondria?
Probably the inner one.
Why?
Because I'm thinking that the outer membrane would have probably formed as a kind of evolution by being in the cytoplasm and being in a eukaryotic cell for like all these years.
Okay, so the inner is in fact more prokaryotic in nature. And if you look, for example, up here at this little guy being ingested, notice that the outer membrane here literally came from the more advanced cell, right? So this little area here shows that. So it is really the most prokaryotic because that bigger cell, it was still prokaryotic, but it was more advanced somehow. It had the ability to eat things. So the outer membrane is more like the plasma membrane of a more advanced cell. So that's kind of the endosymbiont theory. I do want to mention that the badass that came up with this theory is called Lynn Margulis. And I like to mention whenever there is a kick butt female, because most science theories are old white dudes. So I like to point out whenever there's kind of an outlier. And Lynn Margulis is really quite famous for this theory. And at the beginning, people thought she was absolutely nuts. And she just kept coming up with more and more evidence. And then eventually, this is now a very well accepted theory, the endosymbiotic theory, that states that it's kind of the theory that shows how eukaryotic cells evolved from prokaryotic cells by digesting, or not digesting, by eating other prokaryotic cells. And that's how they think both mitochondria and chloroplasts evolved from prokaryotic cells. All right, let me